He knows a lot about the science stuff. Professor Dave explains.
Okay, let's try some problems where we rank according to acidity. So question 1 asks us to rank the following acids in the order of decreasing acid strength, and we have 3 acids there. Number 2 says rank the following acids in the order of increasing acid strength, and we have 4 acids listed there. And then number 3 says rank 0.1 molar solutions of the following salts in the order of increasing pH. So we need to know some things about pH. We need to know some things about acid strength, particularly for oxyacids. So go ahead and check out some of my tutorials regarding acids and bases. And when you're ready, give it a try. So looking at number 1, we know that the acidity of oxyacids increases as electronegativity increases. So for each of these acids, we know that once that proton is lost, that oxygen is going to bear a formal negative charge. And then there is a halogen also connected to that oxygen, and that halogen is going to be able to accommodate some of that negative charge. And the more electronegative that halogen is, the better it is going to accept some of that negative charge, some of that electron density, to help stabilize it. And so that means here the acid with chlorine must be stronger than the one with bromine, which must be stronger than the one with iodine, because we're going in decreasing electronegativity and therefore decreasing acid strength. So 1 greater than 2 greater than 3 is the answer there. Now for number 2, we must remember something else about this particular type of oxyacid, and that is that the acidity will increase as the number of oxygens increases. So here the proton is bound to the chlorine atom, and so when the proton is lost, the chlorine atom will bear a formal negative charge, and those oxygen atoms can help stabilize that negative charge by withdrawing some of that electron density through the chlorine-oxygen bonds. So the more oxygen atoms there are, the better that they will be able to do that. And so this means that in this case, we're going 1 is less than 2 is less than 3 is less than 4. We're getting more and more acidic as we're adding more and more oxygens to that chlorine atom. So that's the correct order there. Now, lastly, we're looking at these solutions of different salts, and we want to put them in the order of increasing pH. So first, let's characterize these. We have NaCl, that is completely neutral, right? We know that chloride ion is exceptionally weakly basic, basically negligibly basic. Then we have ammonium chloride. This will be weakly acidic because of the ammonium ion. We know that the ammonium ion is weakly acidic and can transfer a proton over to water molecules to generate hydronium. Then we have NaCN. That Cn- ion is very weakly basic and will generate an equilibrium with water molecules and generate some hydroxide ion, just a little bit. And then hydrochloric acid is a very strong acid. As we know, it will essentially completely deprotonate and generate lots and lots of hydronium ions. So we needed to know that in order to put these in the correct order. If we're going in increasing pH, we're starting with the most acidic because the lowest pH is the most acidic. So that will be hydrochloric acid first because that's the most acidic, followed by ammonium chloride because that is weakly acidic, followed by NaCl because that is neutral, and then lastly NaCN because that is weakly basic, so that will have the highest pH. So there's a few questions regarding acid strength.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.